The channel would not be complete without videos about testing your code bases. I noticed some development teams endlessly postpone testing because of other priorities, but mainly because they're not confident on how to approach testing. So either there are no tests or a testing project exists but doesn't test much more than you could test manually by using, for example, Swagger. They are often looking for someone to take the lead on this matter, to guide them through the process. After this video, you should feel confident unit testing your code bases using MSTest with the MoQ library. I'll focus on unit testing for this video, which means simply testing your business logic and only your business logic, the methods you wrote for your app features. So not the entire API from request to response, not the authorization, not the validation or other rules present on your API. That's not the responsibility of a simple unit test. I'll show you how to set up your testing project and hopefully answer all your questions about unit testing in C#.NET. Some of these questions might be why to test, what to test in context of unit testing, what not to test, and how to get around certain dependencies. And I'll end the video by elaborating on the numerous tests I've written for my own projects and my opinion about testing, so keep watching until the end. Let's start with why to test. Having tests in place can serve as a great reassurance for the quality of your codebase, but also to rely upon after refactoring. It can quickly give you feedback when something broke after moving code around, or to act as a reassurance just before publishing the code to a live environment. Let me sketch a scenario in which tests can be especially useful. Let's say you are writing your own NuGet package, and let's say your API implements that package. You suddenly have to make changes in the package, publish it, upgrade your API to use the new package version, to then notice, whoops, you wrote a bug into the new package that makes your API malfunction. First of all, this feedback loop is way too long. You should be able to detect this bug before publishing it, and so that's where a unit test could help. Testing can also be hugely beneficial when working with multiple developers on a project, and it is recommended to run your tests before publishing your new code to, for example, your GitHub, and before publishing your code to a live environment such as production. So I briefly answered why to test. Then the remaining questions I summed up should be answered in my demo following shortly about testing with MSTest and MoQ. Let's take a look at the business logic for this demo. My business logic resides in my API project. If it were the case that your business logic resides in a class library, continue with your class library. I opened up the weather forecasts controller that has a get method and a post method. The get method simply fetches all the weather forecasts from the database. The post method allows me to add a new weather forecast to the database if the forecast is at least 24 hours in the future. Let's create our test project. I'm going to add a new solution folder, call it tests. And I'm going to add a new project of unit test project. Going to prefix this with tests.sandbox.api, or you could call it tests.api. Just make sure your namespace is not the exact same as your actual sandbox.api or your class library, wherever your business logic is residing. I'm going to select type MSTest and create. I created this solution folder to keep my test projects separate from my actual runnable projects to not cause any confusion. So let's take a look at what we created. Let's first take a look at the project file. That should have some MSTest packages, enough to run our first tests. Then we have one unit test with a test class and a test method. To run these tests, right-click the testing project and press Run Unit Tests. Then you'll see Test Sandbox API, the class, and the method, thanks to these decorators. Let's head back to our weather forecast controller and make a few remarks. The controller is the place where the request comes in, goes through middleware when applicable, goes through authentication and authorization checks, and might go to validation checks. That makes the controller methods not easy to simply unit test. Because to write a unit test for that, you would have to get around the authentication and authorization, and get around possible validation, and then keep in mind whatever the middleware can do to your data. Also, the controller is quite a complex class. If you check the controller base, there's a lot in there. A lot of things we don't want to deal with for simply testing our own logic. That's why we're going to move our business logic to a service class that has less dependencies, less complex structures. Also, you see the action result, the no content, and the from body that shows there's a lot more going on than simply our own business logic. So we'll extract our own logic out to a simple weather forecast service, and we'll give it an interface, an abstraction that might be beneficial later on. So I moved all the business logic out of the controller into the weather forecast service, a simpler class, and I had to do small modifications, small fixes, but now our code is good to go. We isolated our business logic, and it's ready for testing. And I added one more method, just converting the Celsius degrees to Fahrenheit degrees. Let's head back to the unit tests. I'm going to quickly apply the same folder structure and the tests project as in the actual project. And refactor this one to, let's see, weather forecast service. You could leave it like that, or maybe append it with tests to be more specific, if it isn't specific enough already. If it isn't clear already that we're in the tests folder. The name doesn't really matter, but it's a good idea to resemble the class you're going to test. But it doesn't matter in a way, it's not going to try to match by name or anything. That's not the case. So it can deviate from the actual name. And then the syntax, you can choose it, but often it starts with the method name you want to test. Convert Celsius to Fahrenheit, something like that. And then I often do should. What now? Then the outcome you want, you expect. Or you can say should succeed and then below should fail. If I spelled everything correctly. And now we need to get access to the actual service, to the actual code. So we could say var service equals new weather forecast service, but we have not referenced the project yet, I think. So let's try, no, don't do that. Stupid autocomplete. Let's try if it can reference the project for us. Yep. Like that. And it expects parameters, the logger and the DbContext. So the dependencies we injected in the weather forecast service, these two. So this is where it gets difficult. So this weather forecast service has a dependency of logger, and this logger then has a parameter of logger factory, and then the logger factory has a configuration, needs a configuration, and then the configuration might need something else, and so on and so on and so on. This can get really annoying. So that's where the MoQ library comes in. So MoQ allows you to create mocks, to create dummy objects based upon the real object, and it will resolve the dependencies of that object with other dummy objects. Let's install it on our test project. Let's look for MoQ. So let's create the mocks, but we'll likely want to reuse the mocks in other tests. So we'll make a method in here with test initialize. And I'm going to call it, I think it's, I'm going to call it before each. It's basically going to execute before each test. Then we can say, just a second. And then how it would work would be like this, for logger equals, and then we can say mock, and then off, and specify the type, iLogger. That will have to be the exact type of the actual implementation. So we're gonna pass that. Like that. But now we cannot use that logger because it doesn't know it, so we need to make a private field, read only, iLogger, or is it mock? Let's see. Of course, not read only. We make a logger field and fill it up with the mock. Now we should be able to use the logger as a first parameter, and then we need to still pass the database. So I made a mock object of the database, which works for now, but once we are going to execute a method using the database, it's going to crash because this is not the way to go, but let's more on that later. I made a field for the weather forecast service, which we can now use in our test method. The structure of a test method usually goes as follows. First, you arrange the data, so everything you need of input data you'll arrange at the top. Then you'll call the actual function and catch, and if there's any output, you'll store that in a variable. And then you assert whatever you want to assert. So I'm checking, is the output of the actual function equal to the expected output? I've been a bit lazy. I just copied the the formula, but yeah, it's just a demo. So that's usually the structure. What I also want to mention is you can also have a test cleanup, which would run after each test. You could have a class initialize, a assembly initialize, a class cleanup, and an assembly cleanup as well. Feel free to play around with that. In most of the cases, we have enough with just the before each to initialize our mock objects and our actual objects. So the actual service you don't want to mock because you're just gonna use it. You're gonna use the implementation. There's many more assertions you could do, but of course the R equal makes the most sense for this method. So now this input can also be a variable. That's the cool thing about MSTest. You could say int input, let's just call it input. And then you can add a data row. It's basically going to allow you to add pass values onto your test method. So this would be the same like you just saw before. Let's rename this to should equal instead of should succeed, because we want tests to succeed, of course. Otherwise, we might think there's a bug. And then another test we could call not equal. And we could maybe just make something up, 10 and 20. And 20 could then be the double of expected output. So now we don't have nothing to arrange anymore, but yeah. And let's see, R not equal. And let's run all tests again. And these should all succeed. You could of course add multiple data rows for each method to test more values. You can also add more assertions if it makes sense. For example, is not null or is null, is true, is false. You can try all of those. Throws exception, if the method could throw an exception, all of that. So this was the easy part. We've done some simple unit testing with MSTest and Moq. Now let's look at our actual business logic again. The get method just gets some data from the database, and the create method allows to add a forecast to the database if it's in the future. So this create method has one if statement that will simply return if the requirements are not met. And then at the bottom, another part of the method, when the requirements are met, we add the forecast to the database. So this is what we call an unhappy path, so a failure path, and this is what we call a success path or a happy path. So if we were to test this method, we'd want to cover the unhappy path, and we want tests to cover the happy path. The get method only has one path, and that's supposed to be the success path. Of course, there can be an empty list or a list with many values. Let's start with the create weather forecast. I created a test method and I called it should return early. You might guess which path we are testing here. If you guessed the unhappy path, then you're correct. I applied the same structure, arrange, execute, assert. And let's arrange the data. If we want the method to return early, we'll pick a date that is now and not more than 24 hours in the future, and just pass a temperature. So now we create a weather forecast using this constructed object with a date time of now. This does not have a return value, so yeah, we cannot really assert on the output. So let's see how we're going to test that. It's also an async method. Well, there is no output. In the unhappy part and in the happy part, there is no output. So couldn't really test it. So let's, for the sake of this demo, let's throw an exception in here. Let's say throw new exception. And then of course, we don't want to have this line because we're already calling it in this await assert throws exception async of type exception. You could be more specific with this. And then you pass the method. Let's try that. That was successful. Of course, it says return early. This is no longer correct. Then I should throw exception. Oh, just should throw. Should be good. Let's see. Yep, that all worked. So now I added a test method for the get forecasts. I just try to get the forecasts and store them in a list. I haven't named it yet. We should be, there's only one path, should be the success path, and could say should return list or something, or should succeed. I'll leave that open for now, but this is likely not going to work because of that database Moq. And the test output is telling me on line 28 of the weather forecast service I have a null value, and that's this DbContext. So now you could add the actual database, weather forecasts, what was it again, sandbox DbContext. And then we need to create options and pass the connection string and so on. Let's try it. So you would end up with options like this. New DbContext options builder, use SQL Server, pass the connection string and then get the options, pass the options to the sandbox DbContext and pass that DbContext to your service. So that would work. And then we could, for example, assert whether the forecasts returned were more than 0. And in this case, that is the case. So now, if you clear your database, this test is going to fail, which is not ideal. For some required data, maybe that could be an ideal test, but this is not. We don't really have control over this actual database since the development team might be working on that. And we can't really let our tests rely upon that. Also, it's not the best idea to start altering the database using tests, simply for your own sanity. And also because these tests, since they're unit tests, they're going to bypass the authorization, the authentication, and the validation, and the possible middleware that's on the controller. It's going to bypass all that and then put in some mumbo jumbo data, which might actually do more harm than good. So we're not going to use the actual database. What we will use instead is either an in-memory database, so not the actual database, or a mock of the database. Since we don't really want to test what data resides in our database, we want to test our custom business logic. So whether the code we wrote is valid, is working. That has not much to do with the state of the database. There are, of course, exceptions. Maybe there are some types of tests, not unit tests, but other types of tests, where you want to access the actual database, but not for these unit tests. To get that in-memory database, we need to install a package, not the SQL Server. That's already installed in our API, and we can access that, but an in-memory database, so this package. And we only want that in our testing project, not in our actual database. Let's pick a 7.0.10 stable version. That in-memory database wants a database name, so you can just add that. And let's call it just sandbox. Oops. Okay. Now there's a small problem with calling it just sandbox. It's going to create that database, and then for next run it's going to try to recreate a database again. It's going to error because the database already exists, or yeah, whatever. So a trick would be to add a unique, like a random unique identifier to it. I think people do datetime.now.timestamp or something. Gets the time of day. Yeah, something like that. Let's verify that. Let's change that into ticks. That's going to be more random. It's going to be the time in milliseconds, if I'm not mistaken. And now you're going to get a new database for each run. A fresh database for each run. So what would happen if you don't use this unique database name? It will keep trying to use the same one. And then, for example, test 1 will alter that database state, and then test 2 tests might rely on a fresh, you might expect a fresh database, but you'll have to keep in mind that you altered the state here. So this test might fail because you're expecting different things. So that's not a good idea. That's why we add these ticks to have a fresh database for each test. So maybe an actual database is not what we need either. So then the third option would be mocking a database. So we have even more control over that. So now we're still using an actual database. So to do this get forecasts test, we'll first have to fill that database with some data and then run it and then expect the data to come out. That's maybe not a really useful test, since we just put it in and then we put it out. So we're basically like testing whether the database can store our data or something. Or we might be testing the add async of the DbContext, which is a Microsoft package, so it's not useful to test the libraries that should work fine, that are probably already tested by experienced people. Besides that, we might bump into tracking entity issues or typical database stuff. And we're missing the point again of testing our custom business logic. So the point of the unit test is to test our own custom logic, not to test whether the add async works, not to test whether the database can store any data or return any data. That's not really what the unit tests are about. What you maybe do want to test is just like in the success path, you might want to know, did this add async, did it happen? Did it get called? So we could want to know that, so we're sure we didn't end up in this exception statement or return statement, whatever it might be. So let's try that, and we're going to use MoQ to mock the database and then verify whether that call happened. We don't need any inner workings of an actual database to just test whether the call was invoked. So I'm now going to show how we would do that with MoQ, so how to mock the database. This DbContext is a rather complex object, so it's not simply going to be with MoQ alone, but with MockQueryable as well. I'll show you that in a bit. I am quickly going to move this InMemoryDatabase to its own class, static class, so we can simply reuse that if we need it to. And also the method I showed before that with the connection string. Let's say you do want to access the actual database for some reason, for some other type of test. I'm just going to provide that code in this project as well for you to reuse, maybe for future use cases, because I'll be leaving this code in on my Patreon or on my GitHub repository, and then the code is there for whatever you want to do with it. So that first method, I just made a folder mocks, database mocks, static class, and that just returns the code I just got out of the test method. And I'm going to make another method for the construct actual database with connection string. So that would look as follows, and now we have reusable methods to just say DbContext equals database mocks dot construct InMemoryDatabase. Nice and clean. Before attempting to mock or DbContext from Entity Framework Core, we actually need to take a few steps back to really understand mocking with MoQ. I made up some code to try to illustrate a real scenario that will likely want to mock while testing. I created an interface iMoney service with a method take money out of my bank account. Then the actual money in my bank account is over 9,000, and this method is this, just subtracts the given amount from the money in my account. Let's not forget to register these services. That doesn't really make any difference for testing, but yeah, it's a good thing to do. Also, I notice I'm injecting a service into my other service. I would highly advise against that, to not get into a circular dependency situation. So let's keep imagining that this money service comes from somewhere external, somewhere we cannot access. Okay. I altered the code just a little bit to illustrate this situation better. So let's imagine this money service comes from a private NuGet package behind a VPN. We cannot see what's inside of this service. We cannot access it. We cannot see what this method produces. This take money out of my bank account. Maybe there's some extra transaction costs being deducted, service costs, whatever. So this makes it unpredictable. We cannot predict the output of the method. And we don't want the action to actually take place. We don't want our tests to actually make money disappear from our bank account. So let's start by mocking this out, so preventing this from happening and trying to control the output of this function. So let's go to the weather forecast tests. I created a mock implementation of the money service. I called it money service mock. So now we have the mock implementation, filled it up with an mock instance, but we have to pass the actual instance of iMoney service to the weather forecast service. So we both have the mock instance and the actual instance. Then down below in the code, we can use this mock, set it up. This basically means when the service method take money out of my bank account is invoked with any value, with any double value, return, so we control the output, return 1,000 monies. And then we can verify whether this take money out of my bank account actually got invoked with some value and that it only happened once. At least once, you could say. At least once. Or just once, exactly once, is also possible. By verifying that, we just verified that we didn't get stuck in the unhappy path, but we actually got at least here. Now the next step would be to, now that we have control over this output, we could write a test case, an assertion, to check, to query the database for a payment, maybe the only payment or the most recent payment, to actually have that 1,000 as the amount deducted. Unfortunately, we can't just simply create a mock implementation of the DbContext, since that has the query extensions and more complex, it's a more complex object than our simple service. But it's going to work similarly. I'm going to use MockQueryable to mock the DbContext of Entity Framework Core. So I'll install that package MockQueryable.moq in my test project. Okay. Let's have a quick peek at the documentation page of MockQueryable. Extensions for mocking Entity Framework Core operations such as toList async, first or default async, and all those which are pretty hard to mock without this package. That would go as follows. You basically have to mock every method and whatever is below it. Let's follow a similar logic of the money service. New implementation of the DbContext. Now gonna call it mock. It's gonna be new mock. Yep. And then dot object for the DbContext instance. Okay, so its final form would be you make a list of data you want to act as the mocked data from the DB set from the database, from Entity Framework. You build a mock DB set with that, so the forecasts as queryable build DB mock set. Then you use the DbContext mock and set it up that when the weather forecasts DB set is used to return our own mocked data. So these forecasts, this DB set, based on the forecasts, and then the instance, object instance. Then we can verify on that DbContext mock whether the weather forecasts add async was called. I now did like something more general, so like any weather forecast object, so that's anything in here of type weather forecast. And then the cancellation token is an extra one because the add async supports the cancellation token. And then we want to see if it was called once. I quickly ran the tests and got one error, and that error was about another method, the one I didn't finish, the should, so to simply get requests from the database. But now this database is mocked, so there probably is no data, so we could do a similar thing. But let's first go back to this add async verification. Of course, we put in so much effort to return this 1000 monies. Let's try to verify whether that actually we'd probably want to say like new weather forecast, and then the, what is it, the daytime, we could just say it is any daytime, and then the, what was it again, summary. That summary is actually what we want to see, and we should be, let's see, it should be like something like this. Yeah, of course not just 1000 stringified, and then what was the last one, temperature, I think, and then it is any int, was it? So that will, this might error because the class reference or something. But that is the reason why we wanted to take control over the output of a method we had not under our control. And of course to not actually take money out of our bank account. But then this 1000 would be passed later in the function, and then we could have verified whether this 1000 was actually got into that add async. So if we could have verified that, then we would have been sure the method went as we hoped. as expected. But yeah, I'm not gonna waste time on this. Might still give me an error because of the class reference or whatever. But that was the ID. So we copy pasted the forecasts, the DB set. We set it up to return our own mocked DB set. So there's now, like, you can see this as one row in our table of forecasts, weather forecasts. We call get weather forecast, which simply just returns whatever is in that table. So the list, and then we assert is true if the count is bigger than 0. We could now also verify whether the toList async was called. We could write that test, but it's actually a waste of time, because we would be literally putting mock data in the database to then check whether we put that mock data, whether we're getting that mock database data out of the database. AKA, we're just testing whether the database, like Entity Framework Core, does what it should do, which is not our responsibility. So if we take a look at the get weather forecasts, it's really just doing a database operation, some mapping, but that's not really our custom logic to be tested. So I'm going to leave it there for the testing demo. Entity Framework Core is one of the harder ones to mock and to get right, so that's why I spent some extra time on that. Most of the other services, whatever you use, will be either with a new mock or with a mock off, and it's going to be very similar. Maybe one exception would be AutoMapper. But for that, you can just make a new mapper configuration and just make sure that matches your real application's mapper configuration, and then just pass that mapper configuration, the newly made one, to your as a dependency to whatever needs it. That should work fine, and we're not going to try to verify whether the map method was invoked or whatever, project 2. We just simply want a valid mapper configuration to be passed, so the rest of our function, of our method, happens correctly. So let's recap what to test in the context of unit testing, and that is our custom business logic. There we can test the unhappy parts, and we can test the happy parts. We can write multiple test scenarios. We can try it out with different data, using the data rows, or just writing more tests. What not to test would be someone else's NuGet package. We can safely assume that has been tested. That's not our responsibility. That's not our custom logic. So that could be Entity Framework Core. That could be that money service coming from some private package behind a VPN. That's also, we should be able to assume that works, that is tested when we are implementing the functionality. It's also not the responsibility of our unit tests to test whatever validation logic, authentication, authorization, whatever middleware is active on our request cycle, on our controllers. There are other tests for that, but that's out of the scope of the unit tests. And that's why we extracted our own custom business logic out of the controller to a much simpler service class, much simpler class. And then I showed you how to mock So how to get around certain dependencies, how to mock simple class objects or more difficult objects like the entity framework core DbContext with the DB sets and the queryable extensions and all that. So don't worry about that. Most of the mocks are rather simple, are more like the first mocking we did. So it's not that hard to mock all kinds of dependencies. So then I promised to end the video by elaborating on the numerous tests I've written for my own projects, which is 0. So I have written numerous tests, but it was mostly on the job for the reasons I started the video with, the why reasons. It's not that I'm lazy or that I don't like testing. I really enjoy testing. I think it's a very thankful job. It's a very grateful job. It's also fun to figure out how to mock everything and make everything work, how to dive deeper into the code to understand everything and make sure you cover as much as you can by your tests. It's actually really cool to do. The reason my own code base has 0 tests is because most of my business logic are very simple CRUD operations, so create, read, update, delete. It's mostly just getting some data from the database, then mapping it, and then maybe updating it or whatever. There's not much crazy business logic going on, so that's why I didn't write any tests, unit tests at least. There is probably some logic in my code base, for example doing duplication checks with strings or something that I could write some tests for, but yeah. I'm a very defensive programmer in my defense, and yeah, I test everything manually 1,000 times, and if then still some bugs come out, it's not the end of the world for my projects. I do refactor a lot and I move a lot of code around often, so yeah. But it's just me working in that code base. I know what I'm breaking, if I don't know what I'm breaking, my IDE probably tells me that I broke something, so it's all under my control. I'm aware of my entire code base, so it's not an issue for me. I hope you enjoyed the video as much as I did. Because I really enjoy testing, and I hope to make more videos about testing, but different types of testing. So no longer the unit tests, maybe some other types of testing. So if you did like the video and got some value from it, please hit the like button. Please do subscribe as well. I'm going for at least 100 videos. So stay tuned. Thank you for watching.